For centuries, physics relied on a very specific mental image. We picture the universe as an enormous, empty container, populated by tiny, discrete billiard balls colliding in a void. This view took hold in 1687 with Isaac Newton. His mathematics predicted movement by treating objects as isolated, infinitely small points in empty space. But those classical equations harbor a famous glitch. If you track the gravity between two objects, the math works perfectly. Add a third object, say the Earth, the Moon, and the Sun interacting together, and the calculations shatter. In the late 19th century, Henri Poincaré proved that calculating exact linear trajectories of these three bodies yields impossible chaos. The system becomes completely unsolvable. We assume the math fails because the universe is impossibly complex, but the numbers don't break because nature is flawed. They break because tracking the linear positions of objects is a basic epistemological error. This brings us to a concept called ontic structural realism. It proposes that reality isn't actually made of material things at all. Instead of geometry acting as a descriptive framework imposed on pre-existing matter, the matter itself is a derivative of geometry. Physical properties emerge directly from the mathematical shape of the system. The mass of an atom, or the specific chemical bond of a molecule, isn't determined by microscopic material stuffed inside them. Those physical traits are dictated entirely by their relational shape. The universe is not a collection of objects standing in relation to one another. The structural relationship is the object. If physical reality is built out of shapes rather than physical substances, then what exactly is an atom? To answer that, we have to abandon the idea that space is an empty stage, and time is just a neutral ticking clock in the background recording the action. Instead, picture time as a generative physical matrix. It's a structured fabric capable of continuously stretching, compressing, and folding back onto itself. When this temporal flow varies from one region to the next, it creates pressure differences. Those compressions and folds create the necessary gradients for physical forces to exist. Time is not the stage where the drama of physics happens. Time is the physical substance that changes. This leads to the not-in-time hypothesis. An atom is simply a persistent, self-intersecting fold of this temporal fabric. Its stability comes from topological invariance. You cannot continuously untangle or flatten this knot without physically cutting the loop. It is structurally locked. Because the knot cannot be untied, it acts as an obstruction. It traps the temporal flow, generating localized, persistent patterns that mimic the mass and charge we associate with particles. The atom is a self-sustaining configuration of temporal curvature, a persistent pattern that appears to us as solid matter. How abstract knots solve the historical glitch of the three-body problem? The error was tracking linear coordinates in space. We must instead look at rotational vorticity. This is the curl-curl operator, measuring the vorticity of the vorticity. While linear positions diverge into chaos, this second-order rotation remains constant and periodic. When this double curl remains positive definite, the chaotic motion mathematically phase-locks into a stable orbit. The specific shape of that recurring path is the trefoil knot. By shifting the frame of reference to rotational vorticity, the three-body problem reveals a hidden periodic stability. The unsolvable chaos of position resolves into an elegant orbit of rotation. Engineers are now applying this same topological framework to stabilize the complex behaviors of artificial intelligence. Advanced AI systems are governed by a constitutional Hamiltonian. It uses three competing mathematical layers: a free layer for immediate policy, a fold layer for coherent execution, and a topological layer to protect against cumulative behavioral drift. This data visualization illustrates a single parameter sweep across a topological manifold. It reveals a specific threshold point, the critical boundary where the system maintains topological phase coherence, keeping the AI's behavior aligned with its core rules. This diagram maps what happens when that boundary is breached. The manifold splits. The internal topological knot unravels, resulting in decoherence and a complete loss of governed stability. Reality is a continuous, twisting fabric. Topology dictates physical existence, binding the atoms in our bodies, the orbits of stars, and the minds of machines.